So questions where something is squared, it makes sense that the opposite of squaring is square rooting, and then that solves your question. Now, sometimes you might get an equation like this one, where when you go to square root both sides, the right-hand side is a negative. And so you would have plus or minus the square root of -4. But this is not possible, because you are not allowed to take the square root of a negative number. At least not until like first year university. Then they make up new rules to let you square root negative numbers. What new rules? They introduce a new number. And do you know what they call the number sometimes? An imaginary number. The imaginary number is the number I. And it happens to equal the square root of -1. But we won't, okay, we're not going to go into imaginary numbers. But there's like, right, then they have like jokes like this one here, where pi is saying to the square root of -1, get real. It's not a real number, it's an imaginary number. And then the other one responds with be rational. So good. Okay. So we would say this one has no answers. Sometimes we have questions that say we have x squared plus 6x equals 16. And the problem is if you get the x squared by itself, there's still another x in the equation. And so even though you square root both sides to get rid of the squared, you still have x's on both sides and you have a problem. So what we're going to do is not necessarily look at the algetiles, because sometimes that confuses more than we need. Yeah, we're going to skip all that algetiles. What we're going to do is yeah, they didn't even do it on their textbook. We're going to think about factoring and multiplying things out. I might even just do this one so you can watch. X squared plus, what was it, 6 or 16? 6x equals 16. Now, there exists something that if you square it, something plus something, if you square it, you will get definitely, let's just write it off the top here. Can you see that if you have an x and x from our factoring, the first ones definitely would give us an x squared? There has to be something, I like color coding, there has to be something with the same number here and here, so your outside and inside. So what we got to think about, outside and inside have to make 6. And they have to be the same number because we want something squared. Any ideas? What number would I have to put here and here, so when I add these together, they equal 6, it'd have to be 3. Okay? Now, I'm going to put a 3 there, which means this is very close to x plus 3 squared. But the problem when you do x plus 3 squared, and you actually multiply it out, you'd get x squared, you would get plus 6x, but you'd also get plus 9. You would also have a last term here. That makes sense, right? And so you're like, oh, I really want a plus 9 there, because then this would work out perfectly to be x plus 3 squared, but I don't have a plus 9 there. Math is nice. You want a plus 9? You get a plus 9. Because what do you do in an equation? If I put plus 9 on this side of my equation, I also have to do plus 9 on this side of my equation. Does that make sense? So if you want a plus 9, go ahead. Have a plus 9. You can do that to all your equations from now on. Just add 9 both sides. You'd probably have to subtract 9 on most of them because it wasn't really helpful. But if you really want a plus 9 for a moment, you can do that. So I add the plus 9, and then this nicely works out to x plus 3 squared equals 25. I can now get rid of my squared, because my x is entirely in the square. There's no x's anywhere else. I can square root both sides. Plus or minus 5. Which, if I wanted to get x by itself, I could subtract 3 on both sides. I'm going to temporarily write it like this, and then think, if I use the plus sign, minus 3 plus 5, x would equal 2. Check it out. The original question, 2 squared is 4, plus 12 equals 16. That one works. Or, if I use the minus sign, I would get negative 8. Do a quick check. Negative 8 squared, positive 64. Minus 48 is 16. It works as well. This idea, which they've written in your textbook as well, but it's sort of like add 9 to each side to make a perfect square trinomial. They're basically doing what we're saying, but I like using the FOIL idea, thinking that's 6. This is your hint. And the hint actually is really easy because with this hint, there's a pattern that always happens. Okay? With this hint of 6, this happened to be 3 and 3. Let's say I gave you a different hint. Let's say this time the hint was 10. What has to be here and here? 5 and 5. What happens if the hint was 18? 9 and 9. Can you see that the hint, in order to FOIL out the outside and the inside, if the number is the same, it has to be half? Right? That makes sense? So, that hint, I don't know if you like this, that hint tells us that has to be half. And if you know this has to be half, and that's a 3, how hard is it to figure out the 9? Not very hard at all. Because then you know it has to be 3 squared. So I like thinking of it that way. And then from there, you can solve. We got the 2 answers. And at the bottom of the page, where does it say I'm looking for? They have it nicely highlighted. Do they not have it? They forgot it. At the bottom underneath this, they have a sentence. Okay? On your notes, they have a sentence right there. You're going to highlight that sentence because it is important. It says what this is called. This is called completing the square. And the reason it's called completing the square is because the x squared plus 6x isn't a perfect square yet. You had to add the 9 to make it a perfect square. So if it wasn't a complete square, you had to add it to complete the square. Now, when they show this with algebra tiles, and I'll just show it to you temporarily, they're like, oh, you have x squared plus 6x. If you arrange the x squared plus 6x almost into a square, by putting the x squared, 3 of them there, 3 of them there, you are missing a little bit. What would you have to put into that little bit to complete the square? You would have to put 9 little squares. So they're showing visually that you actually have an incomplete square that you're trying to complete. So we go to example 2, and we want to solve this by completing the square. First of all, I'm going to leave a space because I know I want to complete the square. I'm just going to move the 3 over to the other side. Again, if you want to add 9 to both sides temporarily, you can. You will have to subtract your 9 because that's not going to help us this time. This time, the hint is the 4. If the hint is 4, what would have to be in here? A 2. Right? And if you had x plus 2 squared and you multiplied it out, what would your last term be? 2 times 2. You would need in this space a plus 4. And if I add 4 to this side, sometimes I actually put the space on both sides to remind myself, oh, I added 4 on this side, so I'm going to need to add 4 on this side. And now I have 7 on the right side. Perfect. And as a result, from here, I can now get rid of the squared by square rooting. I remember my plus or minus. Mental math skills have to be good. You always have to double check if you can simplify the square root. But the square root of 7 is its own family, so nothing you can do anymore. Those are our 2 answers, and they will both work. So again, you don't have to verify these equations. When you get 2 answers, both of them will work. Okay, now I'm going to give you some time to try some of these. 5, 8, and 9.